Sorry, it is? I didn't see it. Should be.
Let me check. Oh, I didn't put it on there yet, but I have it. I just need to copy and paste it over. But thank you for telling me. I probably wouldn't have checked it.
Yeah, I bet. Here's all of your glasses. What did you say?
I got sinus infection.
What's going on right now?
I know a lot of people get sick.
I know. And so many people are out with COVID.
Thank you.
Yeah, I got tested, but I was negative for COVID, strep, and flu.
That's what she's telling us.
Yes.
I've never had COVID.
Really?
Derivative is slope.
I don't know.
Yeah, but
Maybe I'm.
light is also light is also like 1 point slope.
Well, derivative is like a formula that tells you the slope at any time. Tangent line is actually a linear line. So there's a lot of overlap in work, but they're not the exact same thing.
You can understand why you do that.
Just because that's what the directions asked to do. The first part of the directions asked for the slope of the tangent line. So I knew we had to write an equation of a tangent line. That's how I knew to do that on that question. It just depends on what it's asking for.
Try.
I was wondering if you had a couple of minutes to fill this out.
I don't right now, but I will try to do it by the end of class.
Okay,
But I
thank
can't
you very
promise.
much. I can come back then if not, no worries. Thank you.
Let's see.
I don't got $30, but I got $11 in
Oh, yeah. Well, no, I mean, I skipped.
There's no rush.
Which is perfect.
Oh, I'm sorry. That's my other class. Forgot to switch it over.
But do we still get this paper?
No.
Satisfied myself this morning.
Sorry, I need the handout back. That's for my calculus class. Unless I'll just one line.
Do we still need a textbook too?
You should not need a textbook.
Okay.
But it's fine. You can put it back.
Okay.
You might need it, so then. Anybody else grab that handout? I need them back. y'all came in early, I had the wrong handout out, so I am passing it out to you. If you came in a little bit later, it was correct. There should be 2 different papers to pick up. Alright, first thing, we got a couple small things to go over in class today, but the first is I need to give you one last chance for any 4.3 book questions. So that was a couple classes ago, we spent the whole class period on it, but some of you didn't finish it in class, and I said you didn't even have to do it for homework yet. And then last class we focused on trig identities, and I said you did need to go back and try the rest of them. And I realize I have all of those worked out on my website, but sometimes that's not enough. And I didn't. So I want to give you a chance to make sure there's not anything else from the book assignment that you needed to ask about. Then we'll be spending the bulk of our time practicing those trig identities that we were working on last time. Remember, some of those can be pretty difficult. And at number 16, we didn't finish up, so I wanted to give you some more class time for that. And then I started asking for some of these assignments in Google Classroom because they will be due before we start class on Monday. So you should start putting those in. And then finally, the handout that you guys picked up or I passed out, this is actually the test review. And even though the test is not for a few more classes, I like to give it to you early because there's a couple questions on here that if you do them before Monday, it's kind of a 2 birds, 1 stone thing. You'll have a little bit more practice in section 4.3, and then you would also have a little bit of the test review done. So the only thing I'm suggesting that you do on that between now and Monday is questions 1 through 4, which is the front page, and question 19, which is the back page. All of that is 4.3 stuff, so all of that is probably on the quiz. So again, if you do it on the test review before the quiz, maybe it will help you with your quiz, and then you'd have it completed anyway. So we need to go in one of 2 ways. If you have some book questions in 13 you want me to discuss with you real quick, then I will. And for those of you that don't, you can pick back up on handout 16 that we were working on last class. So you don't have to wait for us to get there as a group. Okay, so what can I help with? Book questions only right now, and then we'll worry about the other stuff later.
What's the answer to number 4?
The answer to question 4. An angle from horizontal measured up is called an angle of elevation, and an angle from horizontal measured down is called an angle of depression. Not too important right now, but we'll see more of that later. That's it? There's no other book questions? That's good for me, but if y'all have them. Okay, then find in your binder these trig proofs we were looking at last class. So I did a couple of them with you. I think maybe the first 3 or so. I'd ask you to try the other ones on the front page, except for maybe number 8, because I think it's the hardest one. And then I think you had time to try a question or 2 on the back. So, again, I really do think you should maybe save 8 for the end, just because it's the hardest for most students. But what I'd like to do to try to give out some assistance is there any questions on the back page of this that you have tried and gotten stuck on? Because if you have, we could go ahead and start with those questions, and it might benefit you and other people at the same time.
Yeah, 13.
What if I get a copy of that?
on those chairs over there, one of those boxes says quick help handouts, and it's organized by binder numbers. So you just need to take the numbers you need. All right, I'm sorry, you had to tell me a number again? 13? Okay. All right, 13 is a good one to ask because of all of the tools and tips and strategies and stuff that we talked about last class. This did not come up in any of them, but when I look at this one, when I look at this, to me this is over here kind of the same thing, and it's just a different algebra skill. How, anybody got a guess how we might make this look different with algebra? Something we haven't talked about in this class yet. Yeah, what do you think? Make it a
Two binomials.
okay, so factor it. Great. You guys remember if you have something squared minus something squared, the difference of two squares? Remember if you have like a squared minus b squared, it factors as a minus b, a plus b. Yeah? So it's a little bit harder to see, but that's what we've got here. I've got something being squared here. It's cosine squared. I've got something being squared here. It's sine squared. And since it's a difference of two squares, one's a plus, one's a minus. Of course, you could FOIL that together to see that it goes back to the original. So again, the reason I'm glad you're asking that is because even though I have to expect that you guys can factor the difference of two squares, I did not tell you that that was a possibility. We just didn't have time for that. But let's go ahead and finish this question together because we've got about half of the problem behind us now. What is all of this going to come out to be? Sine squared plus cosine squared is 1. That's the first Pythagorean identity. And multiplying anything by 1 doesn't change anything, so I don't really need to keep up with that. Now this one matches the question like the top right of our first handout from last class. What I see is I've got cosines squareds and sine squareds, but I only want cosine squareds. That gives you a hint about what you want to do. You probably want to leave this alone. He's fine to be there. But what's a different way to say sine squared?
Would it be 0 minus cosine?
Close, but not 0. If sine squared plus cosine squared equals 1, then sine squared is the same thing as 1 minus cosine squared. I think you were thinking of the right thing, but do you guys see how that's an improvement? Because I wanted cosine squareds, and this got rid of it and gave me what I wanted. Okay, if that registers as something to try, maybe not something you try in the first 5 seconds, but something that you try, then the rest is pretty easy because you can just distribute and combine like terms. You've got 2 of these and a minus 1, which is what the right side has been the whole time. But what we can all learn out of that is sometimes you need to factor the difference of two squares. And again, I think 16, I think that numerator, I think if you factor him as the difference of two squares, it helps you kind of get started too. So if you're going to ask about 16, I'm going to ask that you hold off on that until you actually follow through and try it at least. And I forgot to put in attendance, so give me just a second. And then I can try to take another one. Seth is out. Lena's out too. 6. Okay, is there another question on the back that you guys have tried and you know you need some assistance on it? Yeah. 9? Okay. Well, I will also add that 9 and 12 look kind of similar-ish. So if you had trouble with 12, you might try the same thing I'm about to do here. So when I look at this, I don't see any algebra that jumps out at me. I don't see anything that needs to be FOILed. I don't see a difference of 2 squares to factor. I don't see much algebra that could be done. I can't add my fractions. But what I could do is I could at least rewrite everything in terms of sines and cosines. I told you guys that that's always kind of your last resort. So instead of saying secant, we can say 1 over cosine. Instead of saying tangent, we can say sine over cosine. Now, you could proceed from here a couple different ways. And honestly, I'm not sure which is the easiest. But from a mathematical standpoint, and we have to do this in calculus sometimes, dealing with these smaller fractions that are in a bigger fraction. This is called a complex fraction. And the easiest way to deal with complex fractions is try to multiply by all the smaller denominators. So since this is divide by cosine, I really want to multiply it by cosine so that those cancel out. But mathematically you can't do that unless you're willing to multiply every term by cosine, which is actually helpful here because I needed that smaller denominator to go away as well. So that leaves us cosine times cosine over 1 plus sine. Everything else cancels out. So again, I really just multiplied everything by cosine to make these smaller denominators go away. Okay, now when I'm looking at this, kind of like the end of last question, if I look at what I have versus what I want, sine, maybe nothing wrong with that, but I certainly don't need this cosine to be here. So you've got to think of some way to replace this. So our 3 Pythagorean identities we have at the top of our page, the first one that gets used the most, it looks like instead of saying cosine squared, I could plug in 1 minus sine squared. And again, I never know for sure if that's really the right path, but you got to try something. Okay, now what can I do with this numerator? Something we used on another question earlier. This is the difference of 2 squares again. Again, it doesn't matter if you guys can factor the difference of 2 squares if you don't recognize it as the difference of 2 squares. You're not always going to have someone looking over your shoulder to give you that tip. This is the difference of 2 squares, then those cancel and leaves behind exactly what you wanted. So again, you may never see this question again. It's not that you need to memorize these steps, but in the future, when you get stuck, it's likely that you need to change things to sines and cosines like I did. If you have smaller fractions within a big fraction, multiplying everything by the smaller fractions is how you get it to not be a complex fraction. If your left side has some cosine squared stuff, but your right side doesn't have cosine squared stuff, you've got to think of some way, like maybe the first Pythagorean identity, to make it look different. And then other algebra stuff, like factoring the difference of 2 squares. If you consider that, then you get it to cancel and leaves what you want. Okay, was that enough for that one? Okay. All right, now I want to give a little bit of direction here. because I know some of you practiced some of these and some of you didn't, but kind of looking at this back page, if you guys would prioritize question, let's say 10 and 11. If you have not tried question 10 and 11 yet, do those first, please, so we can go over them. This is one of the harder things that we do, so jumping into the middle of it's going to
Yeah.
be pretty tough.
I can like watch videos throughout this weekend.
Yeah. We did last class. Did you get the other one? There was another one before this where the questions were a little bit easier to kind of build up to that. So
But
and we did all of those on the class video. I don't want you to have sound on, but if you want to pull up the class recording and start copying that one down, it might help you more than trying to follow us in these when you didn't practice them last time. Sorry about that. Miss Thomas caught me. I need to talk to me real quick. Okay, I'd ask you guys to try 10 and 11 or prioritize those so that if you needed help on them, you could follow along. Of course, if you don't, you can tune me out for a moment. But I think what the most common thing is in number 10 is a lot of people like to split apart our fraction. We saw last class that was pretty helpful. And I'm not saying that you can't do it this way, because I know you can. But dealing with this is a little bit messy. Changing this into sines and cosines, and then dividing this in terms of sines and cosines. Working it all out, you can get it. But what I really wanted to point out about number 10 is there's a much quicker and efficient path, but you got to be paying close attention. So when I see this numerator, and again for the 50th time here, I really think it helps if you have all three of the Pythagorean identities written at top, because if you can just glance at the top and see, wait, that whole numerator is just cosecant squared. If you make that change, cosecant squared divided by cosecant gives you cosecant, just like x squared divided by x gives you x. And cosecant's the same as 1 over sine. You see how that's probably a little easier than splitting apart the fraction? So just trying to give you some options. If you ever see a Pythagorean identity, it's probably easiest if you replace it sooner rather than later. But if you got it by splitting apart the fraction, then that's great too. Anything I want to ask about 10 before I look at the other one? Okay. The other one, 11. I personally think this is probably the easiest one on the back, because if we take these two, what is sine squared theta plus cosine squared theta?
1.
So just because they're not next to each other doesn't mean it's still not the first Pythagorean identity. And then if I can pull up where I had it a second ago, and then again, if you have the Pythagorean identities written out correctly once on the top of your page, you can quickly see, instead of saying 1 plus cotangent squared, you can just say cosecant squared. You can be done with that one in 2 steps. So just try to learn from your mistakes or learn from your inefficiencies. Try to make it a little bit smoother in the future. Anything y'all want to ask about 11 while it's up there? I will. But any questions about 11 first? Okay. Here is 10. And I think 9 and 12 are kind of similar-ish. Yeah, so I'm not going to dictate what order you do the rest of those in, but go ahead and try them, and as I come around I can give you some hints. If I see you going down a path that might be harder than it needs to be, and just see how it goes. But ideally, you can finish this up in class so that you can turn this in, and the bookwork and the notes, all that stuff that Google Classroom's asking for. That way you don't have to remember it for homework. And if you have class time, please try those 5 questions from the test review. So finish this first, but then move on when you're done. Okay. Okay, you could. See, like over here,
these, I could have said they have a common denominator, and I could have pushed those together if I wanted to. So if you prefer to do that, you can, but you don't have to. I don't think it should cancel unless you're multiplying, not adding. Why don't you try it like we did over here? Change this in sine over cosine, change this to cosine over sine, and then multiply away all the smaller denominators and see where you land. Split them up. Where did this guy go?
So the cosine's like 5. Is that believed?
I'm with you to here. I think all of this is equivalent to all of this. Some of the problem from here to here, though, is this should just, like 1 over cosecant is the same thing as sine. So you can write it like that if you want to, but it should simplify to sine at the end, that term. And then over here, this was a cotangent squared.
Plus like minus sine, so like this times cancel out.
Sine this one away. Trying to see what happens. Oh, it looks like you might have tried to move it to the other side. This is cosecant squared. But you can't move stuff over to the other side. So, I'm okay with splitting apart the fraction. 1 over cosecant is sine. But to figure out what this mess comes out to be, you're gonna have to change this to cosine squared divided by sine squared divided by 1 over sine. And then if you divide those fractions by doing multiplying by the reciprocal, then it should work out. So it'll work, but it's not gonna be near as quick as that, the way I did it. That's all I think. And then we did here. Multiply to get rid of the smaller denominators. So multiply everything by cosine to make that go away. Multiply everything by sine to make that go away. Okay, so same as over here. I multiplied everything by cosine to make these smaller denominators go away.
Okay.
So you want to multiply everything by cosine to make that one go away, and then you have to multiply everything by sine to make that one go away.
Okay.
So try that and see what it looks like. Anything I can get done with the back face? Okay. Did you try the 8? I have. Oh, well, I can help you if you erase it though. You should keep what you have down at least. Try to get a common denominator. Why is this one cosine over cosine? No, 1 minus sine squared is just cosine squared. That's not the same thing. The squared matters. Just like Pythagorean theorem, a squared plus b squared c squared, that's always true, but a plus b doesn't actually. The squares make a big difference. Okay, so I don't know that I agree with this. When you multiply by this, what things cancel with this fraction? Okay, and then we use sine times sine, which is
I did 14.
cosine squared,
That's what he told me.
which is just what? Sine squared plus cosine squared is 1. That's the first Pythagorean remedy. So your denominator goes to 1, which is what this denominator is. That's good. When you multiply this by sine cosine, and you multiply this by sine cosine, you also have to multiply this by sine cosine. That's all they're doing. So that's where your part of your answer got lost. These are not equal. That's not the same thing. I'm with you here. Erase this. I'm still going to be sine cosine at the end. Okay, what's your denominator from that one? So sine squared plus cosine. Okay, so your denominator goes to 1. It's just, no, that's your denominator. This is the different one. It is, because that's your denominator is your fraction. The 1 is your denominator. The numerator you have to take. When you multiply this by sine and cosine, so that some of that cancels, and you multiply this by sine and cosine, so some of that cancels, also have another. Every term has to multiply that. And so that's the sine and cosine that you need. And you just lost it, so it wasn't ever gonna work out for that. Let me see if I can get anything fixed. Everything sine and cosine, okay? Okay, so I'm with you here. So when you're doing your work, you can't just start doing this part of the work and ignore this part of the work. You need to keep up with this too. Okay. To me, this looks like, yeah, so it looks like cosine squared. Okay, these become this. What's another way to say cosine over sine? Okay, both squared and the tangent squared. Okay. Okay, so I think this is closer than this. Don't change this one to sine squared. Just leave it cosine squared. Okay. And then usually where people go wrong here is these are the same as this. You've got a cosine squared, you've got a cotangent squared, you've got a negative sign. But subtracting two things is not the same as multiplying. So if you think of this as a fraction over 1, because you change this to a fraction, cosine squared over sine squared. Then you can add your fractions together like you did there, and then those force them together. Okay, that's the part. That's the
No, because that's not square. It's just sine.
That's not square.
I need to ask
That equal with 1 or just 1? No, that's
What did you try?
So this is, oh wait.
Okay, I do want to ask you to try 14 if you haven't yet. 14 is probably the one that had the most questions first period today, and some of y'all are asking me about it. So I will go over 14 on the board, but I want everyone to have a few minutes to try it if you haven't yet. So prioritize that over the others, please. Okay, I'm gonna look at question 14. So if you got stuck on that one, might join me here. So immediately what jumps out at me about this question and how I should proceed is that the left side has two fractions, but the right side has one fraction. So there must be some way to combine these things together. Sometimes that's with identities. In this case, I think it's that we need to add our fractions together. So right now, this is all the left one says. And this is all that the right one says. But to add or subtract fractions, you have to get a common denominator. You don't have to do that for multiplying and dividing, but adding and subtracting you do. So between one plus sign and one minus sign, they both need both of those. So this guy is missing a 1 plus sign, and to keep my fraction balanced, I have to multiply the numerator by the same thing. Multiplying the numerator and the denominator by something is like multiplying by 1, so it doesn't change the size. This one was missing the 1 minus sign, so you needed to multiply the bottom and the top by that. And the whole purpose of getting a common denominator is that we can push those together with the new common denominator. And up here, if I just go ahead and distribute this, I have a cosine, a negative cosine sine, plus, go ahead and distribute this one, a cosine and a cosine sine. So I know it's messier and more intimidating, but all I've really done is add my fractions together. I figured out what the common denominator was, fixed both fractions so they had the common denominator so I could shove them together. After that, you should see that you've got some like terms that add up to 0. We've got 2 cosines in the numerator, which is a good sign because we needed a 2. Might be where the 2 comes from. Our denominator has some sine stuff, but my right side does not have sine stuff, so that tells me it must need to go away somehow. So to me it looks like it's begging to be FOILed. So if I FOIL those, I would end up with this. Now I recognize the denominator as cosine squared. First Pythagorean identity. And then finally, cosine divided by cosine squared would be 1 over cosine. And then there was already a 2 there. So you have to just let yourself get past the intimidation part of how scary it looks. The 90% of the work there was just adding these fractions, knowing that to add fractions you need a common denominator, being able to fix them so they have a common denominator so that you could push them together. After that, all I did was FOIL and then plug in an identity and reduce my fraction. But again, that is one of the more commonly asked ones. So now that it's all up there, is there anything specific about it that I can help with? Okay, I'll come back around. We still got about 40 minutes. So again, still plenty of time. Let me see what you're struggling with.
one of these is almost the first Pythagorean identity. So what is sine squared minus 1 the same thing as? Close. What do you have?
I will switch this over to. You have what, two things? Sine squared minus 1 and sine squared plus 1. So I think one of these is probably a version of the first Pythagorean identity. But there's no way to replace this one, because if you move this over, sign becomes negative, and if you move this over, sign becomes negative, so it must be this one that you can replace. But to get this to be a negative 1, you're gonna have to subtract it over. And then you would have to subtract that over, so it's not cosine squared, it's negative. Right. And if you're doing all that in your head, it's easy to miss that negative sign. Then you can get that to at least cancel with the denominator, and then I think you're one substitution away from function. I'll help you finish it.
Okay, well, if nothing else, what would you do?
Let's go try to take the cosine.
Okay, so say 1 over cosine divided by, now, if you write it like this, it's a little harder to see. So sometimes we write it vertical. Yeah, so just put a divide sign. And then this is already in terms of cosine. Okay, and minus 1. Okay, and then the way we divide fractions, right, so do that. That's gonna come out to secant squared, I think, and then I think this is that. Let's do what's cosine over sine. Okay, so then cosine squared over sine squared is cosine squared.
Fractions, you're gonna change what, that's what you did.
Okay, and then look at here. If you subtract this over, well, if you subtract this over, if you get all the signs right, it's gonna be just an answer.
Yeah, it's gonna be a connection of that.
So I had it like almost right, like I made this the
What?
cosine squared plus 1, but then it ends up with cosine squared plus 2.
The other
It's kind of in the middle of the one.
I'm looking here. But it looks like your denominator got canceled out, so why is there a denominator now?
Oh, because I changed that. It was the negative sine squared, so I changed it to the cosine squared plus 1.
Oh, that's your next line?
Yeah, that was just
Okay,
my
it looks like a
next
fraction,
line.
okay. This is negative sine squared would be cosine squared. Yeah, you're not solving this right. If you have a negative sine squared, you gotta move this over to make it negative. So negative sine squared would be equal to cosine squared, and you're gonna have to subtract this over, minus 1.
I'm sorry, can you say that again?
Negative sine squared. If you initialize this equation for negative sine squared,
It's not what you had. You had solved it for positive sine squared, I think.
Even if that becomes the
I need negative sine squared though, so you need to be moving the sine squared over. Okay.
see what I'm saying? You have this minus one already, and then when you substitute this, you get another minus one. So minus one becomes minus two. Yeah, 'cause it looks like you need to distribute that above the one else. And then the last substitution you need to be looking at, you've got sine squared, but you need cosine squared, so you need to
Try to solve this for sine squared. Instead of saying sine squared, replace it with 1 minus cosine squared. And then it should come out. Well, you have a minus 1 already, and when you solve this for sine squared, you're gonna get another minus 1. Sorry, numbers.
You can't split apart the numerators like that. You can only split apart numerators. So you probably made it an impossible question after that.
Did I do 16? Because I kinda got stuck.
Well, what I would look at if this was on the test, it looks like it's finished okay. So then I would make sure that this is the same as this. I can see these are supposed to cancel, but how did this become this? How did that become that?
I tried to do this and then make sine squared like 1 minus cosine squared.
Okay.
And then plus 1, and then I just did all of that. Like 1 plus 1 is 2, so 2 minus cosine squared, and then divided.
Okay, hold on. I think everything you're doing there is fine, but right here, you've got your signs off. 1 plus 1 would be 2, not minus 2. And you have a negative cosine squared. Okay.
That's true, but then I like just leave divided by -1 because I didn't know what to do.
Right. I mean, that's because you knew what the answer was supposed to be.
Yeah.
So where you lost your negative originally was right here. That is not equal to that.
I thought sine,
Yeah, this is where it helps to have it written out.
and then I could do
Okay, so this needs to be a -1.
equals sine minus 1, and then sine.
Wait. So cosine's on the left. He's positive. You're leaving him on the left. I'm okay with that. How's your sign going from the left side to the right side without switching signs?
Yeah.
Yeah. And plus 1 was on the right, and he's still on the right, so he shouldn't be switching signs either.
Yeah, I got those.
So if you solve that, that's where your negative got lost.
So, well, that's kinda wrong.
No, I mean, you don't need to do, it's just that this also needs to be squares. This isn't true without
Yeah,
squares.
Yeah.
I can square this down real quick.
No, there would be sine squared.
So you needed to replace sine squared minus 1, so here's sine squared, subtract the 1 over, and so for this side to be sine squared minus 1, you gotta subtract that second. Yeah, so just squeeze in a negative there, and then update your data. Yeah. So, right there. This is why this is the hardest one. Sometimes people look at this and they see they've got cosine squared, what they need. That is the same as cotangent squared, which is good, that's what they need. Minus sign, and there's a negative sign. Not quite the same thing, but sometimes you can think you're done fine. But subtraction to me is not the same thing as multiplying something multi-negative. At this point, this looks a lot to me kind of like this. You get a common denominator between these two, and add those fractions together, it's gonna squish it into one big time.
How would I do that?
Well, what's this denominator?
One.
What's this denominator?
Sounds correct.
Okay, so you get a common denominator, you need to multiply the top and the bottom of that by sine squared. Then you can write it as one big fraction.
But would not multiply this by sine squared? No?
If you're multiplying the top and the bottom of the fraction by the same thing, you're not changing the sides.
Oh, okay.
You're not allowed to multiply something to the other side.
Okay.
Try that and see how far you get.
Okay, thank you.
You don't have to do it.
Yeah, but save it for the end.
I just don't.
I bet you can do it.
He said,
Well, on this is like vertical format, you have exact numbers of each other, but sometimes instead of doing it like that, instead of stacking this over this, write it like this. Divide, or fraction bar just means divide. So these are saying the same thing. Change and flip. One over this one. Which is the squared. Okay. And c squared minus 1. I divide all of these by sine squared. Sine squared divided by sine squared. We're almost done. Sine squared divided by sine squared. Anything divided by itself is 1. Cosine squared divided by sine squared. 1 divided by sine squared. And then everything cosine. Write those three at the top. So it's like going to try to juggle more in your head.
I got to the cosine square of this cotangent.
You're halfway there.
Perfect. How do I get?
Well, the first thing is, sometimes people think they're done because you've got a cosine squared, you've got a cotangent squared, but there's a big difference between subtracting something and multiplying it. To me, this one punches out where this one was. You write this as cosine squared over sine squared, you can add these two as a fraction, and then that shows the other term.
Most people don't see that way.
I got to here,
Okay, you're almost done.
Yeah.
Well, what do you need?
I
What trig function do you need? Yeah, to get to the right side.
There's no smart base. Where are you talking about? Where you get that from?
One cosine, but you've got,
I've got it. I know.
okay, well, how, good. So instead of saying sine squared, what is sine squared equal to if you manipulate that?
What's next on Mondays?
Okay, so rewrite this line again, but instead of saying sine squared, replace it with 1 minus cosine squared.
No, just right below it. You still need that.
Yes, it did, bro.
We'll see you.
Mr. Townsend, do we have a quiz next class? You do?
Oh my god.
Yeah.
We had math on the meeting last year. Yes, we did.
Okay, but all of this is just this. 1 minus cosine squared is sine squared.
Okay.
It's still negative of all of that, so you need to do negative parentheses.
Except this is tangent, cotangent, cosine,
And you still have a plus 1 that you have to carry down.
then you're multiplying by.
Is it nice?
All you did was solve sine squared. In place of sine squared, you should put 1 minus cosine squared. Everything else about that should stay the same.
If you plug that in,
You adjust that part, and you still leave the rest of it the same. This is where you're gonna have this one, and then you're gonna create another one, because it's where the 2's gonna come from. And then you've got it in terms of cosine, which is what it wants. So try to finish it. I'll come back.
Yeah.
Okay? You're about halfway there. So this is kind of similar to this. Think of this as cosine squared over sine squared as a fraction.
I hate when you go
You've got two fractions.
That's what
Wait, no, but then I don't have to.
You got two fractions,
Oh my
but
God,
you want the other side to be one big fraction. So just like you did here, get a common denominator, and then you can add those two terms together, and then they'll work out together.
It equals tangent.
This one, we're a little lost.
Number 8. You got the rest of them? I got down to cosine squared minus cotangent.
Good? Well, to me, this is not much different than this now. If you write this as a fraction, cosine squared over sine squared. You could add those fractions. You've got two fractions here. So you get a common denominator, you can add those fractions and make one big fraction like that.
She told me
So
if I
what-
didn't take it, she was gonna be my parents.
I done something wrong. So I got cosine squared theta over sine squared theta minus cosine squared theta over sine squared theta.
Well, those are the same thing. Anything divided, if you're taking something and subtracting it stuff, you get 0. So, change your
Versus zero?
No, you didn't write something right before that. I'm good with this being cosine squared. Cosine divided by secant is cosine squared. I don't know why it's over sine squared though.
It was over.
It's
It was
over sine
over
squared.
1 and you.
Yeah, you gotta get a common denominator. So that's all you
Multiply
do.
by sine squared on this.
You did?
Oh, so I have to multiply by sine squared on one side.
On top and bottom.
One.
If you just make the denominator of a fraction bigger, you just change the size, so now you're trying to prove something that's not one.
Okay.
You multiply the denominator by sine squared, but you need to multiply the top by sine squared too.
Okay. Now we can put them together. Now we got.
How do you do 12?
Similar to 9, so you change everything to sines and cosines, that looks good. You could do a couple different things here, but I noticed the small fractions within the big fraction. So how did we deal with that up there?
Divide them by the denominator.
The small denominators. So multiply everything by cosine to make this one go away. Including the line, so you can forget the
Squared?
Yes, I do.
I keep on getting zero.
I was confused after you did the change it to cosine over.
I'm sorry, I don't know what your hand's in the way, so I can't see.
So like when you
I
multiply,
heard him explain it
Like-
3 times.
So we're multiplying everything by cosine first, okay, so this
Oh, shoot,
becomes
then you go like
cosine,
that.
this cancels that one out, leaves sine, and this one becomes cosine squared, okay, I think you're right. I think it's-
What are you doing over there?
This one
I got
becomes
sine
cosine
squared
squared?
theta times cosine squared theta minus cosine squared
Okay,
theta
over
over sine squared theta.
But we're gonna fix that,
That what you-
how we
gonna
So the same way multiplying everything by cosine.
Why do you solve
Get
this?
rid of
Why do you
that.
solve the sine squared
We still need to
theta?
multiply everything by sine to get rid of that.
But you split them
So now
all together.
multiply everything by sine.
So these cancel out, this is gonna be the cosine.
So
So what, why?
when you multiply by cosine, you multiply by
then-
numerator?
If you multiply a fraction by something, it gets multiplied into correct.
Oh.
How do you get rid of the square?
We're gonna.
Just finish the step.
I don't know.
Multiply everything by sine, just like you did cosine. If you understand why we multiplied everything by cosine, we're doing the same thing for sine. We're still trying to get rid of one more small.
Sine,
I don't know.
Dude, we could have messed up at any
Oh.
point. God, do you see it?
Okay, the only thing is, you multiply this by cosine, that go away.
Do you?
I would multiply that side by side, multiply
Square.
two by sine,
You know what
sine
that
squared.
is?
Why didn't you multiply the numerator? Yeah.
How did you start number 12?
Do you have it
If you
solved?
multiply one thing by sine, everything goes
No, he
multiplied.
doesn't.
Multiply one thing by cosine, everything goes multiplied.
No, he doesn't.
Do you see why?
How
we
many
multiply
times
one
have
by
you
cosine?
been there?
It makes sense.
God, hold on.
Okay, look.
Okay, so you should recognize that denominator now.
Equals one.
This turns
Okay.
into negative cotangent.
Well, hold on, first,
Oh, I see.
And then you're done.
Okay.
Now it's the same as the other side.
Look,
I'm here,
what's on the
okay?
top? You have this on top and then you
I'm
bottom
gonna get
turns into
the
one.
same-
Denominator.
Denominator.
By sine. Both top and bottom.
Yeah, you have to multiply that by sine,
I did.
and that by sine.
But again, the important part is understanding why you
There's no
multiply
sine
everything by
back
sine
there.
and everything by cosine.
So
You
it'd
get
be-
rid of those smaller denominators.
Like that, cause you already got rid of this denominator.
No, not on this side.
On this side you did.
Yeah.
The denominator on this side is 1.
Okay, did y'all have
Yeah,
another one?
but then,
If you
then,
multiply by
After you
sine.
multiply by sine, the denominator is still 1, cause you didn't divide it by anything.
yeah,
No, but you
So it'd be-
multiply the denominator by sine.
yeah.
You gotta multiply.
That's what,
top and bottom.
that's what he said to
See, I forgot about that.
do. Okay, we
See
need,
the point.
we need some assistance over here. So,
Working together, teamwork.
okay. So we got here.
We got it down to here, but then I don't see where you get the ones with cotangent.
Well, you can't cancel out these signs, because this sign is part of the term.
Oh,
Yeah,
yeah.
I got it.
So, we just got sine squared theta minus, times cosine squared theta minus
So if
cosine
you
squared
added
theta.
one.
Correct.
then-
All over
You
sine
split 'em
squared.
up.
You could, I guess, but I think if you split them up, you're gonna go back.
We need just a push in the right direction.
This cotangent.
The top left term and the top right term, what do they have in common?
Oh,
This is so right. I'm just saying it.
That one thing.
So
They equal one.
I'm looking for this.
They're equal to one.
well, cotangent third.
Okay, so factor out cosine squared out of the numerator.
So now
How do we push stupid?
We'll write it down.
What? And that's this.
If I don't get this by 6 months, I'll tell you.
That's why I told y'all to say it.
Everything goes to
I know that. Like, I can't see any other way that would work. Other than put it back.
it would be
Oh, I've got it.
Yeah.
Yes, I do, look, that equals one. No shit, it doesn't.
Why would that equal?
Okay, so.
That does.
No.
That's not.
God, my knees hurt
Well,
so
let's-
frustrating.
Just look at the last couple.
Oh!
Wait.
I can pull out a negative, I can pull out a negative.
Where?
I win.
Okay.
I win.
Where?
That turns into a
Oh, that turns out to a
Okay,
negative
so-
side, but how did this become
So
negative?
just let me
So you
do
do-
this, okay? This is
These two cancel minus.
Those can cancel out, this is part of the term. Things being added or subtracted can't get canceled out
All
like
you
that.
said the same?
So erase these last two little things. You're almost there. You have to fix that up. This one has cosine squared, and that term.
So now.
I can tell you,
Yeah,
it's
because-
like, okay, yeah.
So they both
Right.
have cosine squared. You can factor
Okay,
it
I
out.
feel like we're supposed to get rid of the denominator, but I don't know that.
No.
So put cosine squared, parentheses, you're undistributing.
I'm gonna wing it.
I'm winging it.
Well, is cosine squared times sine this?
Oh.
I'm not a good
You're undistributing.
Cammy got 18.
Who?
Cammy.
He did not give an 18.
On the ACT?
He did not.
18
Not
or
get
28?
He gave him 18.
18 something, is that 32?
I got 26.
I'm just saying.
No, we got, it's
No,
not
that's because
36.
like a.
It's not 36, that's half.
That's pretty good.
Yes.
What did he say?
I take half.
No, you got.
Patrick, maybe with that.
That's what
Alright,
he did.
guys.
19.
Boys, get back on task or y'all need to separate.
Okay, we got a little lost.
Okay, but
We forgot
I don't have any sympathy if you're off that. I'll come in. Okay, you're here.
Yes.
This guy has a cosine squared, this guy has a cosine squared.
Okay.
Okay.
If they both have a cosine squared, I can factor out that DCF.
I'll just factor that.
So factoring out a DCF is undistributing. This times this is supposed to give me that. So this needs to be
Wait.
-1.
cosine squared times 1 is not that.
Oh.
Cosine
One
squared.
plus sine.
Cosine.
Yeah, 1, yeah, that's
Plus.
Cosine squared times what gives you cosine squared times sine squared?
Sine squared.
Sine squared. Oh, that's the only answer y'all aren't giving me.
What are they talking about?
Okay, and then cosine squared times
-1
what gives you this?
-1.
Okay,
Oh, and then that.
Boom.
No way that's right.
He's
Alright.
done.
Well, how do you like know to do that? I haven't learned that you need to take the GCF.
Yes.
I don't know, cause what else are you gonna try?
Wait,
I mean, that's the, unfortunately, that's the answer is, if I don't know what else to try and I see there's a GCF, I try taking it out and then what's left behind looks familiar, so I feel pretty good about that. But this over your denominator is part of your answer, and then if you solve this
Get rid of it like.
using the first Pythagorean identity, I think it gives you the rest of your answer.
Why did we get rid of it then? Wait, I think you can
going back
only
upside
split
down.
You can always put the numerator.
No, I think you can only split the denominator. I think.
Yeah, you can always split the numerator.
Yeah.
I'm stuck.
And then.
Oh, I don't have the answer memorized, you have to look.
You're just as lost as me. So what's your next step? Splitting the numerator.
Well, okay, I figured out how we got the cotangent.
And we got to finish 8, we can't stop it.
Edie. No, I don't think
I'm stuck
you can
here.
because.
Factor difference equals squares.
Oh, it would be
Change
over
this into
Yeah,
negative
over
cosine.
Oh,
If I
over
do
sine.
not.
Because it is clearly because there's triangle.
But hang on.
Cancel these.
Wait, is there triangle?
They don't get it, they don't have it.
There's not a trig. There's five. That doesn't, no,
That's
wait,
okay.
kind of.
Yep, nope.
Still cancel those.
Okay, so it's over
Sine,
sine.
Yeah.
So that's where your
Oh,
cosine.
sine equals 1.
Yeah. Without the
Trying
cotangent.
to do.
But it's.
So where's your one?
Yeah, where's the negative?
So I know
Let me see
that
what you
this is
got.
correct.
Now, you realize you have sine squared, but you need cosine squared.
So that is negative.
Oh, it's
So then
negative, that's
negative
a one.
cosine.
Right, where did you?
But then not.
So where do you get the cosine?
Or maybe the first
Like
Pythagorean
this
identity. What is sine squared?
Is negative cosine squared.
But how, oh, I know.
Because that's what you
Oh,
got.
that's right.
Right, so
Right, that's the first Pythagorean. We got 10 over.
This is right.
You get it? I wanna know what is sine squared equal to. So you gotta
I mean,
subtract this over. Sine squared is the same thing as
He's
minus
laughing.
cosine squared. So write this exact same thing, but instead of sine squared, you gotta put 1 minus cosine squared.
You know you have to.
So 1 minus.
Yes.
Sine.
We just worked it together.
Square equals.
Right? Is that side four, is it real long side?
So then this would.
You see your hand.
Put it over.
No.
Making shortcuts that I'm not asking you to do. Copy this exact
But wouldn't
same thing
the
down.
negative cosine squared also be divided by the sine squared?
Instead of
No, no,
saying
no,
sine
no.
squared.
I turned it in, I'm done with it. I was like,
Cosine of that, there's your, where
Right.
what do you?
That.
No,
What's it?
Okay,
No.
then after those cancel out, the cosine squared.
on 7?
No.
You can't,
This
this
is,
is all one
this is,
thing.
I know I want that.
Oh wait, no, I get it.
Sine squared,
Oh my
yeah,
God,
sine squared, they're the
so-
same thing. I'm asking you to use this.
This is, what is this?
Sine squared.
I'm
Sure.
So cosine
Will you help
squared.
me?
Erase this.
And explain it to
You're
you.
trying to do this stuff in your head.
Cosine squared.
So
Right, the
that
first
whole
one.
is a negative cosine squared, so now you have this one. And then
All
we're
different
dividing all that by
Numerator.
So I
sine
wanna know
squared.
what your sine squared is.
Did that.
One
And to
minus.
divide by sine squared is the same thing, it's multiplying.
One of those.
Good.
Maybe just turn it into
Write down
a,
the
okay.
exact same line. So where your sine
I got
squared
it.
is, you would put one
I
minus
got it.
cosine squared instead.
Times the other great
Yeah.
side and
Yeah.
over
So you have
cosine.
negative.
Squared.
Right, and then the cosine squared and cosine squared.
Copy down
Cancel.
the line of that.
And then you, the negative.
Copy down the negatives, yes. And then it says cosine squared with parentheses.
Minus one.
Sine squared negative
And
30.
then
And then that triggers in.
you turn, right, then you.
Okay, you still have the minus one, that's carried down. You don't part of the last line. So all we're doing is we're making the substitution. Sine squared is one minus cosine. But now that you do that, when you distribute this, you're gonna get a lot of cosine squared is
Hold on.
one. You're gonna have a minus one and a minus one, which is a minus two that you want. So you gotta stop trying to do that.
Wait, how did we
Write it
get
out
that?
and actually solve it so that you make quick substitutions.
The denominator of the denominator.
What?
You get it?
Negative sine
Yeah.
squared plus one.
Yeah, negative sine minus one.
Cosine
But then how do you?
Let me know when you get that.
squared. Use the other negative. And then, so sine squared, just the sine
Six.
squared turns into negative cosine.
Change everything to sine. Right.
And then
And
you
you
have
should,
And then
two
we got
negative
do
ones.
the first four and the last one.
Bam. Plus cosine theta.
I got lost
This
this
is
one.
fine.
The
Okay.
negative numbers
Cosine.
always
Sine.
Plus one. Minus
Okay, I'm kind of
Let's
seeing.
see.
Sine plus cosine. Times cosine.
One.
I think it was
Like
like
Get the rest of that one from earlier.
I
So
think
then
I
those merge
did.
together, and then you got cosine squared.
Well, it looks like you finished it right, so I'm gonna mark this the previous step, that's true. That's,
So then all that merges together.
that's true. That's the previous step.
Sine squared theta.
I am
Over
stuck on
sine
this,
plus.
I got to here and I was trying to listen because I
If you write this one as a fraction,
Wait, I think I got
cosine
it
squared over sine squared, you can get a common denominator, add these two fractions together, and then you go and have two fractions of one fraction. That's the only way it works.
I'm ready to go home this time. I just finished out.
You're multiplying the cosine.
Okay, let's go around in front of me. She pulled me in front of the entire class and made me feel that she was taller.
What this is not okay?
Exactly. I was like, I think just like learning how to, like I didn't use to, like, can you just remember this? It's like,
Make a triangle, so you know this one, make a triangle, equal the adjacent hypotenuse. Find the third side, make a picture.
So rather than rewrite past.
Right, so. You can't find those three last night, one of the drops.
Okay, guys, I need y'all to move back to your seats. I need to give you the directions again real quick before we're out of time. Okay, So I need to remind y'all that there is some stuff to turn into Google Classroom. So some of that stuff has been there for a while. So some of you guys have been turning those things in as they've been there, like the notes and stuff, and that's great. But the other things that it's asking for, if you haven't turned them in, like the book assignment, the basic trig identities that we did all of together, the number 16 that you guys were working on right there that you either finished or got close to finishing, all that stuff needs to go into Google Classroom. We do have the 4.3 quiz next class, but just to make sure that you plan appropriately, I think that quiz is 30 points, but it only has 2 trig proofs. So that's like 6 of the points. Most of the points are going to be like the questions in the book assignment. SOHCAHTOA ratios, finding sides with SOHCAHTOA, finding angles with SOHCAHTOA. You see what I'm saying? 24 of the points, I believe, 24 out of the 30 points come from the book assignment, not this hard trig proof stuff. Only 2 trig proofs. So I'm not saying that you shouldn't look over it to study, but I wouldn't study the trig proofs for 4 hours or anything like that. I think that's not a good plan. I would look back at your book assignment. The first 3 questions in the book assignment were the same, so there's probably one of those on the quiz. The next 2 questions on the book assignment are the same, so there's probably one of those on the quiz. The next 5 book assignment questions were the same, so there's probably 1 or 2 of those on the quiz. So the best thing that you can do for yourself is to make sure you have the basics memorized, the basic trig identities, and review the book assignment. Make sure that you remember how to start those questions. Okay? So don't stress out about the trig proofs at this point. Okay, any questions? Okay, we got about 3 minutes, so if you had something else you needed to ask real quick, then try to squeeze it in, please.